listening Star Academy. So this is our 12th lecture on electromagnetic theory और इस लेक्चर में हम कुछ एग्जाम्पल सॉल्व करेंगे जो सॉलिड सिलेंडर के ऊपर बेस्ड है. तो चलिए सॉल्व करते हैं एग्जाम्पल्स. So our example is that a long cylinder carries a charge density that is proportional to the distance from the axis, that is rho is equal to Cr, that is charge density, rho is equal to Cr, and for some constant C, where C is the constant, and find the electric field outside, on the surface and inside. तो हमारा क्वेश्चन है कि हमारे पास एक लॉन्ग सिलेंडर है, उसकी चार्ज डेंसिटी रो इज इक्वल टू Cr है और C इज एनी कांस्टेंट. तो हमें इलेक्ट्रिक फील्ड फाइंड करनी है आउटसाइड द सिलेंडर, ऑन द सरफेस ऑफ सिलेंडर एंड इनसाइड द सिलेंडर. सो लेट्स कैलकुलेट. सो हियर वी हैव a cylinder of length L, and the radius of this portion is capital R. So this is our cylinder, the central part of the cylinder, and here we have to find the electric field outside the cylinder first. So we have to apply the Gauss law. For that we have to first draw a Gaussian surface. So we draw the Gaussian surface here. So suppose this point is here, suppose this point P is here, and we have to draw the Gaussian surface on this point because we have to find the electric field here. So this is our Gaussian surface. Imagine. We have to find the electric field at this point, and the distance of this point from the center of this cylinder is small r. Okay. And we know that the integral form of the Gauss law, is close integral E bar dot ds bar is equal to q enclosed by epsilon naught. So here q, we have to find first right hand side, then left hand side, and then we have to equate this both, then we will get the electric field. So first find the right hand side. It is, we know that the charge density rho is equal to dq by dv. Okay, so we have to find this dq is equal to rho into dv. So when we integrate this, we will get q enclosed is equal to integral rho dv. So here dv for the cylinder. Okay, so this is the radius r. Okay, so the dv for cylinder is r dr, d phi and dz. So this is the for cylinder. Q enclosed is equal to integral rho into this dv. So this is the volume element for the cylinder. So rho into r dr, d phi and dz. So what is the value of the rho? That is c into r. So this c is the constant, so we take it outside, integral, and the limit of this is the for the r, that is, so first we put this value, then we Cr, this is R, dr, d phi and dz. So this C is the constant, so we will take it outside of the integration. So C integral this R into R is R square, so R square dr integral this d phi and integral dz. So here limit. So this is the our cylinder and this is our Gaussian surface. charge density is the present in the cylinder. Okay, so we have to take the limit of this when we calculate the outside of this cylinder electric field. So आपको जब आउटसाइड इलेक्ट्रिक फील्ड फाइंड करनी होती है सिलेंडर के और किसी भी जो सिमेट्रिक होता है स्फीयर, सिलेंडर और फील्ड बॉक्स एनीथिंग, सो हियर वी हैव टू टेक द जो बॉडी है सिलेंडर उसके बॉडी की लिमिट लेनी। सो यहाँ तक जो डिस्टेंस है वो कितना है, r डिस्टेंस है। q इनक्लोज इज इक्वल टू c इंटीग्रल r स्क्वायर dr इंटीग्रल d फाई इंटीग्रल d से। तो यहाँ पे हमें जो इलेक्ट्रिक फील्ड फाइंड करनी है वो आउटसाइड फाइंड करनी है इस सिलेंडर के आउटसाइड। सो यहाँ पर जब हम r का लिमिट लेते हैं तब हमें जो इस सिलेंडर का लिमिट है वही लेना पड़ेगा, बिकॉज यहाँ तक ही जो चार्ज डेंसिटी रो है वो प्रेजेंट है। इसके आउटसाइड जो हमने गॉसियन सरफेस ड्रॉ किया है वहाँ पे चार्ज डेंसिटी प्रेजेंट नहीं, इसीलिए हमें इसके जितनी चार्ज डेंसिटी प्रेजेंट है और चार्ज डेंसिटी का जो लिमिट है वही लिमिट हमारे इस r का होना चाहिए, ताकि 0 to r and limit for phi is 0 to 2 pi always, and the limit for z is the length of the cylinder is l, so 0 to l. So this is c, this is r cube by 3, limit 0 to r, this is phi, limit 0 to 2 pi, and this is z, limit 0 to l. So here q enclosed is equal to, so we write here q enclosed is equal to c is the constant here and r cube. This is, we put the upper limit, that is r cube by 3, lower limit is 0, so it is 0. This is phi, upper limit is 2 pi, lower limit is 0, and this is upper limit is l. So this is 2 by 3 c pi l r cube is the q enclosed. This is our q1. So we will get the value of q. So we will put this value here in this equation or integral form of the Gauss law. So electric field is the constant everywhere, so we take it outside because it is constant, and the closed integral of this ds. ds is the area, and this area of the Gaussian surface. So our Gaussian surface is in the form of cylinder. So area of the cylinder is 2 pi rl, because this r is this distance or this radius of the Gaussian surface. So this is the 2 pi rl. जो लेफ्ट हैंड साइड होती है वो हमेशा, जब हम लेफ्ट हैंड साइड को जो एरिया होता है वो हमेशा हमारा जो गॉसियन सरफेस होता है उसी का होता है, दैट इज E is equal to 2 by RL, Q enclosed is 2 by 3 C pi L R cube by epsilon naught. So we can write it as this 3 epsilon naught. Okay. So we have to find electric field E bar, that is equal to 2C pi L R cube by this 3 epsilon naught into this 2 pi R L. So here this pi is cancelled, this 2 is cancelled, this L is cancelled. So electric field E bar is equal to C R cube 3 epsilon naught R. This is electric field outside the cylinder. So this is the electric field outside the cylinder. तो अब हम इलेक्ट्रिक फील्ड ऑन द सरफेस ऑफ सिलेंडर फाइंड करेंगे, इसका सेकेंड पार्ट करेंगे। तो ये हमारे पास एक सिलेंडर है जिसकी लेंथ L है और इसका जो रेडियस है वो R है ऑन द सरफेस ऑफ cylinder. So we have to find the electric field on the surface. So I have to find electric field at this point. Okay, this point is on the surface. So we first draw the Gaussian surface. Okay, Gaussian surface कहाँ आ जाएगा? Gaussian surface यहाँ ही आ जाएगा on the surface of this cylinder. Okay, this is our Gaussian surface. So यहाँ से जो दूरी है सेंटर is the R, capital R, और we know that the integral form of the Gauss law is closed integral E bar or ds bar is equal to q enclosed by epsilon naught. That is, again we know the rho is equal to dq by dv. So for dq is equal to rho into dv. So when we integrate this, we will get q enclosed is equal to integral rho dv. Here rho is c into r and the dv for the cylinder is r, dr, d phi and dz. So first we separate this. So here c is the constant, so we will take it outside the integration. So limit of this r into r is r square dr is the Gaussian limit and the limit for this is the capital R. So here again limit of this r is 0 to capital R, r square dr integral d phi. So limit for phi is 0 to 2 pi and the limit for dz is 0 to L. L is the length here. So this is the 0 to L dz. So this is q enclosed is equal to c into 0 to r, r square dr, 0 to 2 pi, d phi 0 to L dz. So the integration of this c into r cube by 3, 0 to r, this is phi 0 to 2 pi and the limit of this is the z 0 to L. So here q enclosed, that is q enclosed is equal to c, where we put this limit here, that is r cube by 3. When we put this limit is 2 pi and this is the L. So q enclosed is equal to 2 pi L C r cube by 3. So this is our q enclosed. So we will put this value here in equation or in integral form of the Gauss law. So here this electric field is the constant here. So E bar, we will take outside this integration and integral ds. So this is the small area ds. When we integrate this small area, we will get the total area. So integral E bar, this is the S, and S is the area of the Gaussian surface. Always remember, when we take the area of left hand side, here this is the area of the Gaussian surface. So we will the area of the Gaussian surface, that is 2 pi, and what is the R for Gaussian surface, that is R, capital R, length is L, that is E bar is equal to 2 pi R L. So here Q is the 2 pi L C R cube by 3 into this epsilon naught. Okay. So E bar is equal to pi L C R Q by this 2 pi R L into 3 epsilon naught. So what is the common here? So this is 2 pi, this is 2 pi, okay, this is L. So 1 R get cancelled, what is remaining is C R square by 3 epsilon naught. So this is the electric field on the surface of the cylinder. This is the electric field on the surface of cylinder. So when electric field inside the cylinder, so we have to find the electric field inside the cylinder. So this is the integral form of the Gauss law. Using this we will find the electric field outside on the surface and inside the cylinder. So here third case is inside. So here we have a solid cylinder of radius of this is capital R. Okay, we have to find the electric field inside this cylinder. So we have to find at this position, electric field at this position. So we draw the Gaussian surface here. Okay, this is our Gaussian surface. Okay, and this distance is small r. So at this point we have to find the electric field. So here we know that this is the Gauss law or integral form of the Gauss law. Rho is dq by dv. It is dq is equal to rho into dv. So dq or integration of this is the q enclosed is equal to integral rho dv. So this rho is C into R, so we put this value here, integral CR, and the dV for the cylinder is R dr, d phi and dz. This is the volume element for the cylinder. So this is Q enclosed is equal to integral C is the constant, so we take it outside C. This is R square dr, this is integral d phi and this is integral dz. So here limit is for this r is 0 to r. We are finding the electric field inside this cylinder. In this case we have to take the limit for this r is the Gaussian limit, because here is जो चार्ज डेंसिटी है प्रेजेंट है यहाँ पे और जो लिमिट है उसका वो 0 टू स्मॉल r है, तो इसकी वजह से हमें जो लिमिट लेना है r का वो 0 टू r है. दैट इज q enclosed is equal to c into r cube by 3 0 to r. This is limit for phi is 0 to 2 pi and the limit for z is 0 to l. So this is phi 0 to 2 pi and this is z 0 to l. So here q becomes q enclosed is equal to, put this limit here, c, that is r cube by 3 into this limit, that is limit of this phi is 0 to 2 pi, that is 2 pi, upper limit is 2 pi because lower limit is 0, and here limit for z is 0 to l, upper limit is l, lower is 0. So q enclosed is equal to c 2 2 pi CL r cube by 3. So this is our Q enclosed when we are finding the electric field inside this cylinder. So we have to find the electric field here. So we equate this to left hand side and right hand side. So this is electric field is the constant, so we will take it outside. This is integration ds bar. So integration ds bar is, this is the ds is the area of the Gaussian surface. So here the area of the Gaussian surface is 2 pi, r is the small r, so 2 pi rl. This is Q enclosed is equal to 2 pi CL r cube by 3. This is upon epsilon naught. So electric field E bar is equal to 2 pi CL r cube upon 2 pi RL 3 epsilon naught. So what is the common here? 2 pi common, L is common, 1 R is cancelled. So what is remaining? C R square 3 epsilon naught. So this is the electric field inside the, this is electric field inside the cylinder. तो चलो हम यहाँ पे जो रो है इसकी वैल्यू चेंज करके प्रैक्टिस करते हैं. अगेन वी चेंज दिस वैल्यू. रो इज इक्वल टू C by R cos square phi. So using this value of rho, we can calculate the electric field outside on the surface or inside. So let's start. Suppose we have a, first we find the outside. Suppose we have this cylinder, and we have to find the electric field outside the cylinder. So the cylinder has a radius r, length L, and we have to find the electric field outside this. So this is point P, and we have to find the electric field here. So first we have to draw the Gaussian surface. So for that, draw this Gaussian surface. This is the Gaussian surface. Okay, this is the Gaussian surface, and the distance of this point is from this cylinder is, the center of this cylinder is small r. Okay, we know that the integral form of the Gauss law is integral E bar dot ds bar is equal to Q enclosed by epsilon naught. So we know that the charge density, which is volume charge density, rho is equal to dq by dv. So dq is equal to rho into dv. So we have to find the value of q. So integrate this, that is q enclosed is equal to integration rho dv. Here the value of rho is integral c by r cos square phi, and the value of dv for the cylinder is r dr d phi and dz. So here this c is the constant, so we will take it outside. The integration, this 1 by r, this r dr, integration cos square phi d phi, and the integration dz. So limit of this integration is, okay, we have to find the electric field outside this cylinder. So we have to take the limit for this. Take the limit of this is body limit, because here the electric charge density, volume charge density जो यहाँ पे present है up to this है. Okay, outside this जो Gaussian surface है वहाँ पे तो present नहीं है, इसीलिए जहाँ तक हमारी चार्ज डेंसिटी प्रेजेंट है वहीं तक हमें लिमिट लेना है। तो इसीलिए हम यहाँ लिमिट 0 टू कैपिटल R, जो इसकी बॉडी का लिमिट है वही लेते हैं। दिस इज लिमिट फॉर दिस इज 5 0 to 2 pi and limit for this thread is 0 to L because the length of this is L. So here this R get cancelled, it is C 0 to R dr 0 to 2 pi this cos square phi d phi and the 0 to L dz. So here integration of this is C R 0 to R. This is the integration of cos square phi and limit is 0 to 2 pi. In this case, when full limit or half limit is present and sin square theta or cos square theta is present, then we have to a simple trick, that is 1 by 2 into the limit of this integration, that is the limit is 2 pi. That is we have to write 1 by 2 into 2 pi. Okay, if here is cos square theta or sin square theta and limit is 0 half or full, it is 0 to pi or 0 to 2 pi. So in that case we can write it as directly 1 by 2 into limit of this 2 pi, or when that is cos square theta is equal to 1 plus cos 2 theta by 2. Using this formula also we can calculate, but this is the trick. So we can use this trick here. So and the integration of this is z, and when we put this value 0 to L. So here Q enclosed is equal to C. Put this limit, that is capital R. This is 1 by 2 and this is 2. This cancel, so remains pi and this is the N. So Q enclosed is C R pi N. So we will get the value of Q here. So we have to find the electric field. So here electric field is constant, so we will take it outside, and the integral of this closed integral of this ts bar, that is this ts is the area of the Gaussian surface. So here this area of the Gaussian surface is 2 pi and this is radius is RL. So E bar into 2 pi RL is equal to, what is the value of Q? It is C R pi L by this epsilon naught. So E bar is equal to C R pi L by epsilon naught into 2 pi RL. So here what is common? This pi, this L. Okay, it is C R by epsilon naught R. This is the electric field outside the cylinder. This is the electric field outside the cylinder. So we have to find the electric field on the surface of cylinder. So first we rub this. So here we have a cylinder. Okay. That is, radius of this is capital R. The length of this is L. So we have to find the electric field on the surface of cylinder. So first we have to draw the Gaussian surface. So Gaussian surface is on the surface of the cylinder. So this distance from the center is, this radius is the r. So it is, we know that rho is equal to dq by dv. So this dq is equal to rho into dv. When we have to find the q, so integrate this, q enclosed is equal to integration rho dv. And here the value of rho is the c by r cos square phi dv. So here q enclosed, it is 0 to capital R, because the charge density is present this limit and this is also body limit. So 0 to r, and this dv is r dr d phi and dz. So here this r get cancelled, this is dr, c take outside, 0 integration 0 to 2 pi cos square phi d phi and integration 0 to L dz. So this is c into, this is r, so 0 to r, this. So here integral 0 to 2 pi cos square phi d phi and integral 0 to L dz. So here 0 to 2 pi cos square phi d phi. So in this case, when integral 0 to 2 pi or integral 0 to pi यानी कि full limit or half limit and cos square phi and d phi or sin square phi or d phi, at that case we have to write this integration 1 by 2 into the limit of this integration, that is 2 pi. तो अब यहाँ पे लिमिट 0 to 2 pi और 0 to pi cos square d phi और 0 to 2 pi और 0 to pi sin square d phi होती है, और वहाँ हम इसका जो इंटीग्रेशन है उसे डायरेक्टली लिख सकते हैं 1 by 2 into 2 pi. This is the 2 pi is this limit for this. So this is 1 by 2 into limit of this integration. So in that way we can write. Otherwise you can solve this using this formula. Cos square theta is equal to 1 plus cos 2 theta by 2. And this is the z. So this is 0 to L. So this is q enclosed is equal to c. The limit of this is r. This 2 get cancelled, pi, and this is the L. So this is the q enclosed. So we have to find the electric field. So the electric field E bar ds bar is equal to q enclosed by epsilon. So here electric field is the constant, so we will take it outside. The integral ds bar, ds is the area of this जो हमारा ऑन द सरफेस है वही का एरिया, तो गॉसियन सरफेस है, गॉसियन सरफेस का एरिया इट इज 2 pi r l is equal to, what is the value of q, that is c in r into pi into l by epsilon naught. So E bar is equal to c r pi l by 2 pi r l into this epsilon naught. So electric field E bar is equal to this L get cancelled, R get cancelled, this pi get cancelled, that is C by 2 epsilon naught. This is for on the surface. This is the electric field or on the surface of cylinder. So now we have to find the electric field inside this cylinder. So this is the cylinder and this is the point. At this point we have to find the electric field this inside the cylinder. So we draw this Gaussian surface and the distance from the center of this point is the small r. So we know that rho is equal to dq by dv. So dq is equal to rho into dv. So integration of this is q enclosed is equal to integration. What is the value of rho is c by r cos square phi, and the dv for the cylinder is r dr d phi and dz. So here c is the constant, so we take it outside. C 0 limit for this r get cancelled, dr, and limit for the r is the Gaussian limit. So here is the charge density present, and the limit of this is this Gaussian surface. So here we take the Gaussian surface. When we have to find the electric field inside this, so we will take the Gaussian limit, and when we have to find the electric field outside the cylinder, then we will take this body limit 0 to capital R. And when we have to find the electric field inside the cylinder, we will take the limit 0 to small r, that is the Gaussian limit. Okay, so integral 0 to 2 pi cos square phi d phi and integral 0 to L dz. So here C, this is R, the limit of this 0 to R, and this is the 0 to 2 pi cos square phi d phi. So here the limit is full, that is 0 to 2 pi, and here cos square phi d phi. So in that case we have to take 1 by 2 into the limit of this integration, that is 2 pi. So this is 2 pi. जब भी आपको ऐसा इंटीग्रेशन सॉल्व करना हो, जब वहाँ पे जो इंटीग्रेशन की लिमिट हो 0 to 2 पाई और 0 to पाई हो, और वहाँ पे जो इंटीग्रेशन लेना है वो cos स्क्वायर फाई डी फाई और sin स्क्वायर फाई डी फाई हो, तो इन दिस केस वी कैन राइट इट एज 1 by 2 into the limit of this integration, that is 2 pi, that is 1 by 2 into 2 pi. Otherwise we can solve this by using this formula, that is cos square theta is equal to 1 plus cos 2 theta by 2. Okay, अगर आप इस तरह से भी सॉल्व करेंगे तो आंसर वही आएगा. So इसलिए this is small trick, so we can write in this way. So this is the z, so 0 to L. So here C, we have to put this limit is R. So this 2 get cancelled, this pi, and this is the L. So Q enclosed is equal to CR pi L. So we have to find the electric field, that is electric field is constant, so we will take it outside electric field. Integration of this is ds bar. So ds bar is the integration of the, or this is the surface, integration of the surface of the Gaussian. Okay, Gaussian surface. So this is the E bar. This is 2 pi RL, because this R is this is the distance of this point from the center of this. So this is 2 pi RL is equal to, what is the value of Q? Q is CR pi L by epsilon naught. So here we have to find the E bar. So this is the E bar is equal to CR pi L by 2 pi RL into epsilon naught. This L get cancelled, this pi get cancelled. So this R get cancelled. What is remaining? C by 2 epsilon naught. This is electric field inside the cylinder. So this is electric field inside the cylinder. So again we change the value of rho, and we will find the electric field outside, on the surface and the inside. So the value of the rho is, rho is equal to C R square cos phi. Okay. So again we calculate the electric field outside, on the surface and inside. Now for the value of rho, it is Cr square cos phi. So again we have a cylinder and the length of this is L, the radius of this is R. So the integral form of the Gauss law is closed integral E bar dot ds bar is equal to Q enclosed by epsilon naught. So we know that the rho, that is volume charge density, is equal to dq by dv, and we can write it as dq is equal to rho into dv. So when we integrate this is q enclosed is equal to integration rho dv, and the dv, that is volume element for the cylinder, is r, dr, d phi and dz. So here the value of rho is integral c r square cos phi into r, dr, d phi and dz. So here we separate this. So here c is constant, so it is outside, and the limit of the, we have to take outside. Okay. So we have to take this r into r, that is r cube dr integration cos phi d phi and integration dz. Okay. Limit for this r is, we have to take the body limit because we take point outside. We have to draw this Gaussian surface for that point. So this is r distance, but up to this is charge density is present, so that's why we have to take this limit, that is 0 to r, this is 0 to 2 pi and this is 0 to L. So here Q enclosed is equal to, this is r raised to c into r raised to 4 by 4, the limit of this is 0 to r. Here this is the integration of cos phi is sin phi, the limit of this is 0 to 2 pi and the integration of this is the z, limit of this is 0 to L. So here c, this is r raised to 4 by 4 and this is sin 2 pi minus sin 0 into L. So here sin 2 pi and sin 0, that is both are 0. 0 minus 0 is, this term is 0. Because of this, whole term is 0. So here charge is 0. So Q enclosed is 0. So here charge is 0. That's why the electric field inside is 0. Electric field outside is 0 and electric field on the surface is 0. Because here is no any charge, so here is no any electric field.